Good morning, Ma'am Daliwanag. My name is Rachel Pastores, and I'm currently taking BSBA Management Information System, and I would like to present my course project and data and communication in Networking 4. And the topic that I choose to discuss is the topic group 1, which is point-to-point connection, the branch connections, and the access control list. And for the topic 1, point-to-point connections, we have the objectives, configuring HDLC encapsulation, explain the fundamentals of point-to-point serial communication across a WAN, configure HLDC encapsulation on a point-to-point serial link, explain how PPP operate across a point-to-point serial link, compare PPP and HDLC, explain the PP layered architecture and the function of LCP and NCP, explain how PPP establish a session, configure PPP encapsulation, configure PPP encapsulation on a point-to-point serial link, configure PPP authentication, and troubleshoot PPP. To troubleshoot PPP using the show command and debug command. Point-to-point protocol. The PPP is a WAN protocol that works a layer 2 by encapsulating frames for transmission over a variety of physical links such as serial cable, cell phones, fiber optic cable, among others. It offers many more features as compared to HDLC, and it is an open standard. Some of the features that is offered which are not available in HDLC include link quality management, which is a way to monitor the quality of a link in PPP. When PPP detects too many errors on a link, the link is shut down. Authentication using APA and or CHAP. PPP operate is made using 3 parameters: the encapsulation of frame using HDLC protocol, the LCP or the link control protocol for establishment, configuration, and testing of the link, and the NCP or the network control protocol to negotiate the different layer 3 protocol. Link control protocol or the LCP, this is the main protocol that PPP uses for its operation. The link control protocol works on the top of layer 1 and its work by establishing, testing, and configuring this physical connection. It is also negotiate other WAN options that are handled by NCPs. The LCP configure the link in a way listed below. Determine transmission of different packet sizes, detection of misconfiguration errors, termination of the link failure. The LCP is also used to negotiate encapsulation parameter and other PPP configuration options such as authentication, error detection, and completion when the link has been established. The Network Control Protocol Layer or NCPs are protocols that allow PPP to use different layer 3 protocols such as IP, IPX, and AppleTalk. The serial and parallel port. A WAN is owned by a service provider and a LAN is a typical owned by an organization. Point-to-point connection connect LANs to service provider, WANs, and connect LAN segments. A LAN to WAN point-to-point connection is also referred to as a serial connection or leased line connection. Lines are leased for a carrier. Companies pay for a continuous connection between 2 remote sites and the line is continuously active and available. This is the example of our LAN, router LAN, and And we have here the one which is the service provider network. Here's the example of our serial port point-to-point connections. Another example for serial and parallel ports. We have here the topologies for the point-to-point connection. On the most PCs, parallel port and RS-232 series serial ports have been replaced by the higher speed serial universal series bus SUB interfaces. The serial communication method of data transmission, in which the bits are transmitted sequentially over a single channel, equivalent of a pipe only wide enough to fit one ball at a time. Multiple balls can go into a pipe but only one at a time, and they only have one exit point, the other end of the pipe. The parallel communication, its bits can be transmitted simultaneously over multiple wires. Send a bit 8 bits in the time that a serial connection send a single bit. At one time, most PC included both serial and parallel ports. Parallel ports were used to connect printers, computer, and other devices that required relatively high bandwidth. The point-to-point connection links. The point-to-point connection link, point-to-point link used when permanent dedicated connections are required, provides a single pre-established communication path. Path goes from the customer's premises to the provider network to a remote destination as shown in the figure. Here's the example of our point-to-point link topologies. We have here the LAN 1 and the LAN 2, and we have here the 1, and we have here the premises like the New York office and the London office. Can connect to geographically distant sites such as corporate office in New York and regional office in London, not limited to connection that cross land undersea fiber optic, usually more expensive than shared services. Constant availability is essential for some applications such as VoIP or video over IP. The serial bandwidth. Bandwidth refers to the rate at which data is transferred over the communication link. The carrier technology will dictate how much bandwidth is available. North America, T carrier specification, Europe, E carrier system, US optical carrier OC bandwidth points. The OC transmission rate are set of standardized specification for the transmission of digital signal carriers on SONET fiber optic network. Here we have the example of the carrier transmission rate. We have the line type and the bit rate capacity. For one encapsulation protocols, data is encapsulated into frames before crossing the one link and must be configured for the appropriate layer 2 protocol. Choice of protocol depends on the WAN technology and the communication equipment. WAN protocol, HDLC, and PPP are the focus of this course. HDLC is a default encapsulation on point-to-point connection, dedicated links and circuit switch connection when the link uses two Cisco devices. The PPP provides router-to-router and host-to-network connection over synchronous and asynchronous circuits. has built-in security mechanisms such as PAP and CHAP. Here we have the example of the WAN encapsulation protocols. Serial Line Internet Protocol, or SLEEP, displays by PPP, X.25 Link Access Procedure Balance, or LAPB, predecessor to Frame Relay. Frame Relay data link layer protocol that handle multiple virtual circuit after X.25. ATM, or International Standard for Service Relay, in which devices send multiple service types such as voice, video, or data in fixed length 53 bytes cells, take advantage of high-speed transmission such as E3, SONET, and T3. HDLC encapsulation. HLDC is a synchronous data link layer protocol developed by the International Organization for Standardization, or ISO. HLDC defines a layer 2 framing structure that allows flow and error control through acknowledgments. Default serial encapsulation method when connecting to Cisco router. The Cisco's HDLC is a point-to-point protocol that can be used on leased line between two Cisco devices. Protocol field makes it possible for a single serial link to accommodate multiple network layer protocol. Here we have a figure compares standard HLDC to Cisco HLDC. We have the standard HLDC, the plug, address, control, data, FSS, and the plug. Support only single protocol environment. Uses a frame delimiter or plug to mark beginning and end of each frame. With an added protocol type, field Cisco HDLC can only work with other Cisco devices. Configuring HLDC encapsulation. Use Cisco HLDC as a point-to-point protocol on leased lines between two Cisco devices. If connection non-Cisco devices, use synchronous PPP. If the default encapsulation method has been changed, use the encapsulation HLDC command in interface configuration mode to re-enable HLDC. Here we have the example of configuration. We have here the interface, the SO00-0-0, and the encapsulation HLDC. Troubleshooting a serial interface. To troubleshoot the serial interface, the show interfaces serial XXX command display information specific to serial interfaces. When HLDC is configured, encapsulation HDLC should be reflected in the output as highlighted in the figure. Here's the example of our troubleshooting command. And here we can also see it's the encapsulation HLDC is highlighted, and the serial is up, line protocol. The serial 000 is up, line protocol is up, indicates that the line is up and functioning. Troubleshooting a serial interface. Here, the serial interface issue associated with state and how to troubleshoot the issues. Here we have the status line, the possible condition, and the problem solutions. This is the example and how we can solve the problem if the connection is not working. And to troubleshoot a serial interface, we gonna do the show controllers command. Output indicates the state of the interface channel and whether a cable is attached to the interface. If the figure interface serial 000 has a B.35 DCA cable attached. And for packet tracer troubleshooting serial interface, here's the example of the packet tracer troubleshootings. Topologies. Introducing PPP. The PPP encapsulation should be used when there is a need to connect a non-circle router. PPP encapsulation data frames for transmission over layer 2 physical link. PPP establish a direct connections using serial cables, phone line, trunk line, cellular telephones, specialized radio links, or fiber optic link. The PPP contains three main components: the HLDC, like framing for transporting multiple protocol, packet over point-to-point link, extensible link control protocol or LCP for establishing, configuring, and test the data link connection, and the network control protocol for establishing and configuring different network layer protocol, IPv4 and IPv6 control protocol. Here we have the example of HLDC is the default encapsulation method on a serial link, and we have also the use PPP encapsulation to connect a Cisco router to a non-Cisco router. At the advantage of PPP, PPP includes many features not available in HDLC. The link quality management feature LQM monitor the quality of the link. The LQM can be configured with the interface command PPP quality percentage. If the error percentage falls below the configured threshold, the link is taken down and the packet are rerouted or dropped. The PPP support PAP and CHAP authentication. The PPP layer architecture. The figure maps the layered architecture of PPP against the Open System Interconnection OSI model. Here we have the network layer, the data link layer, and the physical layer. The PPP requires a full duplex circuit, either dedicated or switch, that can operate in a synchronous or synchronous bit serial mode. Most of the work done by PPP happen in the data link and network layer by LCP and NPC. At the physical layer, PPP can use synchronous physical media such as leased line service, asynchronous physical media such as those that use basic telephone service for modem dial-up connection. PPP link control protocol. The LCP function within the data link layer and has a role is establishing, configuring, and testing the data link connection. LCP establish the point-to-point link. LCP also negotiate and set up control option on one data link, which are handled by NCPs. After the link is established, PPP also use LCP to agree automatically on encapsulation formats such as authentication, compression, and the error detection. For a physical layer, the physical layers is synchronous or asynchronous is a physical media. For data link layer, authentication, other options, link control protocol, and for the network layer, network control protocol or NCP. PPP use LCP to offer service option. The service options are primarily used for negotiate and frame checking when implementing the point-to-point control specified by an administrator. The Network Control Protocol or NCP, PPP permits multiple network layer protocols to operate on the same communication link. For every network layer protocol used, PPP used a separate NCP as shown in the figure. IPv4 uses IP control protocol and IPv6 uses control protocol. NCPs include functional fields containing standardized codes to indicate the network layer protocol that PPP encapsulates. The value 8021 is equals to IPCP, the value 8057 is equals to IPv6CP. PPP uses the PPP frame structure. Here we have the field length in bits, the plug, the address, the control, the protocol, the data, the FSC, and plug. A plug is a single bit that indicates the beginning or the end of the frame. The plug field consists of the binary sequence 1, 0 to 1. The address is a single bit that contains a binary sequence 1, the standard broadcast address. The control is a single bit that contains the binary sequence 000011 which calls for transmission of user data in an unsequenced frame. The protocol, 2 bits that identify the protocol encapsulated in the information field of the frame. The data, 0 or more bits that contain the datagram of the protocol specified in the protocol fields. And for frame check sequence or FCS is normally 16-bit, 2 bytes. If the receiver calculation of the FCS does not match the FCS in the PPP frame, the PPP frame is silently discarded. Establishing a PPP session. Here we have the example of our phase 1, link establish, shall we negotiate. The phase 2, determine the quality. Maybe we should discuss some details about quality or maybe not. And for the phase 3, network protocol negotiation. For phase 1, link establish and configure in negotiation, before PPP exchange any network layer datagram such as IP, the LCP must first open the connection and negotiate configuration option. This phase is complete when the receiving router sends the configuration acknowledgement frame back to the router, initiating the connection. And for the phase 2, link quality determination, the LCP tests the link to determine whether the link quality is sufficient to bring up network layer protocol. For phase 3, network layer protocol configuration negotiation, after the LCP has finished the phase 2, the appropriate NCP can separately configure the network layer protocol and bring them up and take them down at any time. If the LCP closes the link, it informs the network layer protocol so that they can take appropriate action. For LCP operations include provision for 3 classes of LCP frame: the link establishment frame, the link maintenance frame, and the link termination frame. Here we have the examples of our table link establishments. We have the LCP configuration, the initiate LCP configuration / request, complete LCP configurations ACK, and NCP configurations NCP packet exchange. During the link establishment, the LCP opened the connection and negotiate the configuration parameter. The link establishment process starts with the initiating device sending a configuration request frame to the responder. Responder processes the request. If the options are not acceptable or not recognized, the responder sends a configure not or configure reject message. If the options are acceptable, the responder responds with the configure ACK message and the process moves on the authentication stage. The operation of the link is handed over the NCP. When NCP has completed all necessary configuration, including validating authentication, the line is available for data transfer during the exchange of data LCP transmissions into link maintenance. LCP operation. During link maintenance, LCP can use messages to provide feedback and test the link. The echo request, echo reply, and discard request. This frame can be used for testing the link. Code reject and protocol reject. These frame types provide feedback when one device receives an invalid frame. The sending device will resend the packet. Here's our example of LCP operation. LCP in operation link termination. After the transfer of data at the network layer completes, the LCP terminates the link. NCP only terminates the network layer and NCP link. The link remains open until the LCP terminates it. PPP can terminate the link at any time because of loss of the carrier, authentication failure, link quality failure, the expiration of the idle period timer, or the administrative closing of the link. The LCP closes the link by exchanging terminating packet. Device initiating the shutdown sends a terminate request message. Other device reply with the terminate ACK. For PPP configuration options, here we have a topology of our two LAN routers and the one link, authentication PAP or CHOP, and the compressions. We have also the multi-link, authentication using either APE or CHOP, compression using either stacker or predictor, and multi-link that combines two or more channels to increase the WAN bandwidth. For the NCP PPP configuration options, after LCP has established the link, the router exchanges IPCP messages negotiating options as specific to IPv4. IPCP is responsible for configuring, enabling, and establishing the IPv4 modules on both ends of the link. IPCP negotiates two options: the compression. Compression allows device to negotiate an algorithm to compress TCP and IP header and save bandwidth. The IPv4 address allows the initiating device to specify an IPv4 address to use for routing IP over the PPP link, or the request of IPv4 address for the responder. After the NCP process is complete, the link goes into open state and LCP takes over again in a link maintenance phase. When data transfer is complete, the NCP terminate the protocol link and LCP terminate the PPP connections. This is our example. The NCP explain how it works. The compressions. Two compression protocol available in Cisco router are Stalker and Predictor. The error detection identifies fault conditions. The quality and magic number option help ensure a reliable loop-free data link. The PPP callback is used to enhance security with this LCP option. A Cisco router can act as a callback client or a callback server. Here we have the configurable option fields codes. We have the option name, option type, the option length, and the descriptions. The PPP basic configuration commands. Remember that PPP is not configured on a Cisco router. The default encapsulation for serial interface is HLDC. PPP is a layer 2 encapsulation that supports various layer 3 protocols including IPv4 and IPv6. The PPP compression command is a point-to-point super compression on a serial interfaces can be configured after PPP. After PPP encapsulation is enabled. Because of these options evoke a super compression processes, it can affect system performance. Here we have an example for our configurations and our example for our topologies. The PPP link quality monitoring command. The PPP quality percentage command ensures that the link meets the set quality requirements, otherwise the link closed down. Percentage are calculated for both incoming and outgoing directions. Configuring PPP quality 80 shown in the figure sets minimum quality to 80%. Here's the example of our configurations using percentage command. And for PPP multi-link commands, multi-link PPP provide a method for spreading traffic across multiple physical WAN links. Configuring MPPP requires two steps as shown in the figure. For step 1, create multiple bundle. Step 2, assign interface to the multi-link bundle. To disable PPP multi-link, use no PPP multi-link command on each the bundle interfaces. Here's our example of no PPP multi-link command configurations. And for verifying PPP configuration, verifying PPP serial encapsulation configurations. To verify it, we just need to do the show interface serial, the serial number, and it will give us the result of encapsulating the PPP LCP open and the interface and the multi-link. We can also do the show PPP multi-link. This will also show us the bundle name and the other serials, member links. The command, the show interfaces, display the show interface displays statistic for all interface configuration over the router. display information about serial interface, and the show PPP multilink will display the information about the PPP link interfaces. For a PPP authentication protocol, the APA is a very basic two-way process with no encryption. The username and password are sent in plain text. If it is accepted, the connection is allowed. CHAP is more secure than APA. It involves a three-way exchange of shared secret. The authentication phase of a PPP session is optional. If used, the peer is authenticated after LCP. Establish the link and choose the authentication protocol. Authentication takes place before the network layer protocol configure phase begins. Here we have the PAP, the PAP two-way handshakes. We have the username, the router 1, and the password. We have the remote router and the central site router. And for CHAP three-way handshake, we have the remote router and the central site router. And we have a challenge. For password authentication protocol, or APA, initiating PAP, R1 sends its PAP username and password to R3. Note that the APA is not a strong authentication protocol. Using APA, passwords are set across the link in plain text, and there is no protection from playback or repeating trial and error attack. Completing PAP, R3 evaluate R1 username and password against its local database. If it's matched, it accept the connection. If not, it reject the connections. Challenge handshake authentication protocols. R1, R3 initiate the three-way handshake and send challenge message to R1. The R2, the remote node responds with the value that calculate using one-way hash function. The 3, the local router check the response against its own calculation of the expected hash value. If the values match, the initiating nodes acknowledge the authentication. Note that the chef conducts periodic challenges to make sure that the remote node still has a valid password value. Excuse me. The PPP authentication command, to specify in the order in which the CHAP or PAP protocol are requested and the interface, use the PPP authentication interface configuration command. Use the no form of the command to disable this authentication. The PAP, CHAP, or both can be enabled. If both methods are enabled, the first method specified is requested during link negotiation. If the peer suggests using the second method or simply refuses the first method, the second method should be tried. Here's the example of our PPP authentication command. For configuring PPP for authentication, CHAP hostname one router must match the username the other router has configured. The password must also match, occur on link established, and can be repeated. For PAP, hostname on one router must match the username and the other router has configured for PPP. The password must also match. Here's the packet tracer configuration PEP and CHAP authentication examples. We can see here our topologies for we here are the example of packet tracers And here we also have the lab configuring basic PPP with authentications topology. To troubleshoot PPP serial encapsulations, debug PPP command parameters. Here's the example. We have here the PPP authentications command. We have the parameter and usage. The debug command must not be used as monitoring tools. Meant to use for short period of time troubleshooting. Can consume a significant amount of resources. For packet, display PPP packet being sent and received. This command display low-level packet dumps. For negotiation, display PPP packet transmitted during PPP startup, where PPP options are negotiated. For error, display protocol error and error statistic associated with PPP connection, negotiate and operation. Authentication, display authentication protocol messages including challenge authentication protocol, CHP, CHAP, packet exchange, and password authentication protocol or PAP exchange. For compression, this will display the information specific to the exchange of PPP. And connection using MPPC. This command is useful for obtaining and correct packet sequence number information where MPPC compress is enabled and the CBCP display error and statistics associated with PPP connection negotiation using Microsoft Callback Control Protocol. Here's our example. Here's the troubleshooting example using the debug PPP. And the troubleshooting a PPP configuration authentication. Here we just need to do the debug PPP authentication. It will give us the list of the serial, the remote message authentications. And for packet tracer troubleshooting, a PPP configuration or authentication. Here are example for our PPP configuration or authentication, and for the lab troubleshooting basic PPP authentications. And for our topic 2, the branch connections. For the objectives, select broadband remote access technology to support business requirements. Compare remote access broadband connection option for small to medium-sized businesses. Select an appropriate broadband connection for a given network requirements. Configure a Cisco router with PPP OE. Explain how PPP OE operates. Implement a basic PPP OE connection on a client router. Explain how VPN secure site-to-site and remote access connectivity. Describe benefits of VPN technology. Describe site-to-site and remote access VPNs. Implement a GRA tunnel. Explain the purpose and benefits of GRA tunnel. Implement a BGP and a single home remote access network. Describe the basic BGP feature. Explain the BGP design consideration and configure an ABGP branch connections. The cable components. Two types of equipment are required to send signal upstream and downstream on a cable system. The cable modem termination system or CMTS and the headed of the cable operation. The headed is a router with database of providing internet. The cable modem CM on the subscriber's end. The broadband connections. The cable system uses coaxial cable that carries radio frequent RF signal across the network. A hand-edged CMTC communication with CMs located in subscriber's home. The HPS HFS network is a mixed optical coaxial network in which optical fiber replaces the lower bandwidth coaxial cable. Here's our example topologies for our broadband connections. What is DLC's connections? The DLCs, or the digital subscriber line, is a means of providing high-speed connection over installed copper wires. A schematic DLC provide higher downstream bandwidth to a user that upload bandwidth. Symmetric DLC provide the same capacity in both directions. For satisfactory ADLS service, the local loop length must be less than 3.9 miles or 5.46 km. Here's the figures show a representation of the bandwidth space allocation on a copper for ADLS. The plain old telephone system identifies the frequent range used by the voice grade telephone service. The area labeled ADSL represents the frequency space used by the upstreams. For DSL connections, the broadband connection, we have the two important components are the DLS transceiver and the DSLAM. The advantage that DSL has over cable technology is that DSL is not shared medium. Each user has a separate direct connection to the DSLAM. Here's our example topologies for, we have here the DSL modem and the microfilters. We have the provider network and the DSLAM ISP. For wireless connections broadband, development and broadband wireless technology are increasing wireless availability to three main technologies. We have the municipal Wi-Fi. Most municipal wireless networks use a MIS of interconnection access points. Each access point is arranged and can communicate with at least two other access points. The mesh blanket a particular area with no radio signal. The cellular or mobile phone use radio waves to communicate through nearby cell tower. The cellular mobile broadband access that consists of various standard and the satellite internet service are used in locations where land-based internet access is not available, or the temporary installation that are mobile. Internet access using satellite is available worldwide. Here's the example wireless connections topologies. Comparing broadband solution. Selecting a broadband connection. Each broadband solution has advantage and disadvantage. Some factors to consider in making a decision, which include the cable. Bandwidth is shared many users. Upstream data rates are often slow during high usage, or in areas with oversubscriptions. The DSL limited bandwidth that is distance sensitive in a relation to the IPS central office. Upstream rate is proportionally quite small compared to downstream rate. The fiber to home requires fiber installation directly to the home. The cellular mobile coverage is often an issue, even within a SOHO where bandwidth is relatively limited. The Wi-Fi mesh, most municipalities do not have mesh network deployed. If it is available and the SOHO is in the range, then it is viable options. The satellite is expensive, limited capacity per subscribers, often provide access where no other access is possible. For our PPPOE overview, the PPP can be used on all serial links, include those links created with dial-up analog and ISDN modem. PPP support the ability to assign IP addresses to remote ends of the PPP link. PPP support CHAP authentications. Ethernet link do not natively support PPP. PPP over Ethernet provides a solution to this problem. The PPPoE creates a PPP tunnel over and Ethernet connections. For implementing PPPoE configurations, the dialer interface is created using the interface dialer number command. The PPP CHAP configuration usually define one-way authentications, therefore, the ISP authentication the customers. The physical Ethernet interface that connects to the DSL modem is then enabled with the command PPPoE enable. The dialer interface is linked the Ethernet interface with the dialer pole and PPPoE client commands using the same number. The maximum transmission unit MTU should be set down to 1492 versus the default of 15 to accommodate the PPPoE header. For the verification, the show IP interface brief command is issued to verify the IPv4 address automatically assigned to dialer interface by the ISP router. The show interface dialer command verifies the MTU and PPP encapsulation configure the dialer interfaces. The show PPPoE session command is used by display information about currently active PPPoE session. The Ethernet MAC address can be verified by using the show interface command on each router. And for troubleshooting, verifying PPP negotiation using the debug PPP negotiation command to re-examine the output of the debug PPP negotiation command. And for support an MTU of only 1492 bits in order to accommodate the additional 8 bits PPPoE header. The IP TCP address -MSS max segment size interface command adjusts the MSS value during the TCP three-way handshake. For the verifications, here's our basic configuration verifications. Using the commands to verify the PP, we can use the show IP interface brief to verify the IPv4 address automatically assigned. The show interface dialer verifies the MTU and the PPP encapsulation, show the IP route, and show the session. This will display the information about the currently active sessions. To troubleshooting, the following are possible cause of problem with PPPoE. Failure in the PPP negotiation process, failure in the PPP authentication process, and failure to adjust the TCP maximum segment size. Negotiations. Use the debug PPP negotiation command to verify PPP negotiation. For possible point of failure of PPP negotiation, no response from the remote device. Link control protocol not open. Authentication failure. IP control protocol failure. For authentications, verify that the CHAP username and password are correct using the debug PPP negotiation command. For MTU size, PPPoE support an MTU of only 1492 bits in order to accommodate an additional 8 bits PPP-oe header. Use the show running config command to verify the MTU. The ISP TCP adjust MSS max segment size interface command prevents TCP session from being dropped by adjusting the MSS value during the TCP three-way handshakes. Here are the example of adjusted maximum segment size with PPP-oe header. Introducing VPNs. A VPN is a private network created by tunneling over a public network, usually the Internet. A secure implementation of VP with encryption, such as IPsec, IPVNs, is what is usually meant by virtual private networking. The implementing of VPNs in VPN gateway is necessary. Could be a router, a firewall, a Cisco Adapted Security Appliance, or ACA. For the benefits of VPNs, these include the following: the cost savings. VPN enable organizations to use cost-effective high-bandwidth technology such as DSL to connect remote offices and remote users to the main site. The scalability, organizations are able to add large amount of capacity without adding significant infrastructure. Compatibility with broadband technology allow mobile workers and telecommuters to take advantage of high-speed broadband connectivity. Security, VPN can use advanced encryption and authentication protocol. For the site-to-site VPNs connect entire network to each other. For example, connecting a branch office network to a company headquarters network. Here's the example of our site-to-site VPNs connections. In a site-to-site VPN, end host send and receive normal TCP IP traffic through a VPN gateway. The VPN gateway is responsible for encapsulating and encrypting outbound traffic. For remote access VPNs, support the needs of a telecommuter's mobile user and extranet traffic, allow for dynamically changing information, and can be enabled and disabled. Used to connect individual hosts that must access their company network securely over the Internet. The VPN client software may need to install on a mobile users and end devices. The types of VPNs. The DMVPN, or the Dynamic Multipoint VPN, is a Cisco super solution for building multiple VPNs. The DMVPN is built using the following technology. The Next Hop Resolution Protocol creates a distributed mapping database of public IP addresses for all tunnel spokes. The Multipoint Generic Routing Encapsulations Tunnel GRE Tunnel interface allow a single GRE interface to support multiple IPsec tunnel. The IP security, or IPsec encryption, provides secure transport of private information over a public network. Here's our example topologies for our dynamic multipoint VPNs. For our GRE introductions, the generic routing encapsulation, or GRE, is a non-secure site-to-site VPN tunneling protocol developed by the Cisco. The GRA manage the transportation of multi-protocol and IP multicast traffic between two or more sites. A tunnel interface supports a header for each of the following: an encapsulated protocol, or passenger protocol such as IPv4 or IPv6, an encapsulation protocol or carrier protocol such as GRE, a transport delivery protocol such as IP. The characteristics of GRE is defined as IETF standard or RFC 2784. In the router, IP header 47 is used in the protocol field. The GRE encapsulations use a protocol type, field, and GRE header support. The encapsulation of any OSI layer 3 protocol. The GRE is stateless. GRE does not include any strong security premises. Header, together with the tunneling, IP header creates at least 24 bits of additional overhead for tunneled packets. To configure the GRE, we have the 5 steps to configure a GRE tunnel. Step 1. Create a tunnel interface using interface tunnel number command. Configure an IP address for the tunnel interface, usually a private address. Specify the tunnel source, the IP address. Specify the tunnel destination, IP address. Optional, specify GRE tunnel mode as a tunnel interface mode. And to note, the tunnel source and tunnel destination command interface the IP address of the pre-configured physical interface. Here's the example of our grid tunnel configurations and our basic configuration commands. To verify the GRE, use the show IP interface brief command to verify the tunnel interface is up. Show the interface tunnel command to verify the state of the tunnel, and to show IP OSPF neighbor command to verify that OSPF adjacency has been established over the tunnel interface. And to troubleshoot the GRE, issues with GRE are usually due to one or more of the following: the tunnel interface IP address are not on the same network, or the subnet mask do not match. Use the show IP interface command. The interfaces for the tunnel source and or destination are not configured with the IP correct address or are down. Use the show IP interface brief command. And to static or dynamic routing is not properly configured, we can use the show IP or show IP OSPF neighbor. Here we have the packet tracer configuring GRE example topologies, and we also have the troubleshooting GRE topologies, and the lab configuring a point-to-point GRE VPN tunnel topologies. For the BGP overview, the IGP and AGP routing protocols. IGP are used to exchange routing information within a company network or an autonomous system AS. An exterior gateway protocol, AGP, is used for exchange of routing information between autonomous systems such as IPS. Border Gateway Protocol or BGP is an exterior gateway protocols, AGP. Every AS is assigned a unique 16-bit or 32-bit AS number which is uniquely identified in the Internet. The eBGP and iBGP. The external BGP is a routing protocol used between router and different autonomous systems. The internal BGP is a routing protocol used between routers and the same AS. Two routers exchanging BGP routing information are known as BGP peers. When not to use the BGP. The BGP should not be used when one of the following conditions exists. There is a single connection to the internet or another AS known as single home, when there is a limited understanding of BGP. Note that although it is recommended only in usual situation for the purpose of this course, we will configure the single home-based BGP. Here's our example of our topologies connections between the AS6500 companies. This is the ABGP connections, and the ISP-1. BGP options. 3 common ways an organization can implement BGP in a multiple home environments. The default route only, default route and ISP routes, and the all internet routes, which would include router over 5,500 networks. Here's the step for configuring the ABGP. And to configure the BGP commands, there are the 3 steps to implement: the enable BGP routing, configure BGP neighbor peering, and advertised networks originating from this AC. The command to the command router BGP as member, this describe a BGP routing process and place the router in router configuration mode. For router, neighbor IP address remote as specifies a BGP neighbor, this as number is the neighbor AS number, and for network, advertise a network address. The network mask is the subnet mask of the network. Here's the example configuration of ABGP. The router BGP as number global configuration commands enable BGP and identifies the AS number. The neighbor IP address remote as a member router configure command identifies the BGP pair and its AC number. Company A configured router BGP 65 company. The network address network mask router configuration command enter the network address into the local BGP table. Note that the network address used in a network command does not have the direct command network. To verify the ABGP, we have the 3 commands to verify it. Is to show IP route, to show IP BGP, and to show IP BGP summary. Here's the example packet topologies to configure and verify the ABGP, and to our lab configure and verify the ABGP topologies. And for our topic number 3, which is the access control list and objectives, configure standard IPv4 ACLS, explain the purpose and operation of ACL and small to medium business networks, compare standard and extended IPv4 ACLs, configure standard IPv4 ACLs to filter traffic in small to medium sized business network, configure extended IPv4 ACLS, explain the structure of an extended access point entry or ACE, configure extended IPv4 ALS to filter traffic according to the network requirement, troubleshoot ACLS, explain how router processes packet when the ACLS is applied, and troubleshoot common ACLS error using the CLI command. What is the purpose of CLS and what is ACL? An ACL is a series of iOS commands that control whether a router forward or drop packets based on information found in the packet header. The ECLs are not configured by default on a router. ECLs can perform the following tasks: limit network traffic to increase network performance. For example, the video traffic could be blocked if it's not permitted. Provide traffic flow control. ECLs can help verify routing updates are from unknown source. ECLs provide security for network access and can block a host or a network. Filter traffic based on a traffic type such as telnet traffic. Screen hosts to permit or deny access to network service such as FTP or HTTP. Here's the example of our topologies about ACL. For a packet filtering, an ACL is a sequential list of a permit or deny statement note as access control entries or ACE. ACEs are commonly called ACL statement. When network traffic passes through an interface configured with an ACL, the router conveys the information within the packet against each ACE in sequential order to determine if the packet matched one of the ACEs. This is referred to a packet filtering. Packet filtering can analyze incoming and outgoing packet, can occur at layer 3 or layer 4. The last statement of a ACL is always the implicit deny. This is automatically inserted at the end of each ACL and block all traffics. Because all ACL should have at least one permit statement. ACL's operations. ACLs do not act on packets that originate from the router itself. ACLs define the set of rules that give added control for packets that enter inbound interfaces, packets that rely through the router, and packets that exit outbound interface of the router. Can be configured to apply to inbound traffic and outbound traffic. Inbound ACL, incoming packets are processed before they are routed to the outbound interface. Outbound ACL, incoming packets are routed to the outbound interface and they are processed through the outbound ACL. Here's our example of our inbound and outbound ACL. Introducing ACL wildcard masking. IPv4 ACE required the use of the wildcard mask. A wildcard mask is a string of 32 binary digit ones and zeros used by the router to determine which bit of the address to examine for a match. Wildcard matches are often referred to as an inverse mask, since unlike a subnet mask where a binary 1 is matched, a binary 0 is matched with wildcard match. Here's the example of our wildcard masking. The wildcard mask example, calculating the wildcard mask to match IPv4 subnet, takes practice in the first to the left. The example 1, the wildcard mask stipulates that every bit in IPv4 192.198.1.1 address must match exactly. Here's our example of our wildcard mask to match IPv4 host and subnets. The wildcard mask stipulates that anything will match. The wildcard mask stipulates that any host within 192.168.1.0/23 network will match. To calculate the wildcard mask, here's the example of our wildcard mask calculations. And our wildcard mask keywords. To make wildcard mask easier to read, the keyword host and any can help identify the most common uses of wildcard masking. The host substitute for the 0.0 mask, any substitute any substitute for 255 if you would like to match the IP 192.169.10 address, you could use 192.168.10.0 or you can use the host 192.168.10. Here's the example of our wildcard mask abbreviations. And here's also another example for our wildcard mask keywords. For general guidelines for creating ECLs, use ECLs and firewall routings positioned between your internal network and external network such as internet. Use ECL on a router position between two parts of your network to control traffic entering or exiting a specific part of your internal network. Configure ECL on border routers such as those situated at the edge of your network. This will provide the basic buffer from the outside network that is less controlled. Configuring ECLs for each network protocol configured on the border router interface. Here's the example of our ECL traffic filtering on a router. The purpose placement on an ECL can make the network operate more efficiently. For example, an ECL can be placed to reduce unnecessary traffic. Every ECL should be placed where it has the greatest impact on efficiency. Extend ECLs configure extended ECLs as close as possible to the source of the traffic to be filtered. This will prevent undesirable traffic as close to the source without uncrossing the network infrastructure. For standard ECL, since standard ECLs do not specify destination addresses, these should be configured as close as the destination as possible. Here's the example of deny a specific host and permit a specific subnet. Topologies. For a standard ECL placement, this example demonstrates the proper placement of a standard ECL that is configured to block traffic from IP 192.168.10 network to 192.168.30 network. There are two possible places to configure the access list on router 3. If the access list is applied on a S001 interface, this will block the traffic. This is the example of a standard ECL placement. For number standard IPv4 ECL syntax, here we have the parameter and the descriptions, the access list number of a ECL. This is a denial number from 1 to 99 or 1300 to 1099 for standard ECL. The deny access if the conditions are matched. Permit access if the conditions are matched. Remark: add a network about intern IP access list to make list easier to understand this scan. And for applying the standard IPv4 ECL to interface, after standard IPv4 ECL is configured, it is to link to an interface using an IP access group command in interface configuration mode. Here's the example of our configuration using the command IP access group. To remove an ACL from an interface, first enter the no IP access group command on the interface and then enter the global no access list command to remove the inter ACL. Number standard IPv4 ACL examples. Here's our topology examples. The figure to the left showing the example, these permit the traffic from a specific subnet but denies traffic from a specific host on a subnet. The no access list command deletes the previous version of ACL. The ACL statement denies the host 192.168.10. What is another way to write command is without the host is all other hosts on 192.168 network are then permitted. There is an implicit deny statement that matches every other network. Next, the ACL is reapplied to the interface in the outbound directions. Configuring standard IPv4 ACL. Here's the example of the number standard IPv4. And to name standard IPv4 syntax, identify an ACL with a name rather than with a number marks. It's easier to understand its function. The example of the left show how to configure a name standard access list. Notice how the commands are slightly different. Use the IP access list command to create a name ACL. Names are alphanumeric, case sensitive, and must be unique. Use permit or deny statement as needed. You can also use the remark command to add documents. Apply the ACL to the interface using the IP access group name command. To verify the ACL, use the show IP interface command to verify that the ACL is applied to the correct interface. The output will display the name of the access list and the direction in which it was applied to the interface. Use the show access list command to display the access list configured on the router. Notice how the sequence is displayed out of order for the no access list. This will be discussed later. This is the example of our basic command to verify the ACLs. ACL statistic. This shows access list command can be used to display match statistic after a ACL has been applied to an interface and some testing has occurred. When traffic is generated that should match an ACL statement, the matches shown in the show access list command output show increase. Recall that every ACL has an implicit deny any at last statement. The statistic for this implicit command will be displayed. However, if this command is configured normally, the result will be displayed. The clear access list router command can be used to clear the counter for the testing protocols, for the testing purpose. The access class command, administrative BTY access to Cisco device should restricted to help improve security. Restricting BTY access is a technique that allows you define which IP addresses are allowed remote access to the router access process. The access class command configure and line configuration mode will restrict incoming and outgoing connection between a particular BTY into Cisco device and the address in the access list. Router config line access class access list number. To verifying the BTY port is secured, verification of the ASLC configuration used to restrict BTY access is important. The figure of the left shows two devices trying to SSH into two different devices. The show access list command output through the result after the SSH attempt by PC1 and PC2. Notice the match result at the permit and deny statement. Use the example topology to verify the BTY port and to know if our security is secured. To troubleshoot ACLs, processing packet with ACLs ACLs, the implicit deny any. A single entry ACL with only one deny entry has the effect of denying all traffic. At least one permit ACE must be configured in the ACL or all traffic will be blocked. Study has two ACL in the figure to the left. Here's the example of our processing packet with ACL, entering criteria statements. The order of ACE ACS is an ACL. The order in which ACL are configured are important since ACS are processed sequentially. The figure to the left demonstrates, use the figure, the difference between two statements since they are in the wrong order. The first deny statement block every in the 192.168 network. However, the second permit statement is attempting to allow host 192.168.10 through. This statement is rejected since it is a subset of the previous statement. Revising the order of these two statements will resolve the problem. Processing packet with ACLs, the Cisco IOS reorder standard ACLs. Note the order in which the access list statement were entering during configurations. Notice how the order was changed when entered the show running config command. The host statement are listed first, however, not in the order they are entered. The IOS put host statement in order using special hashing function. The resulting order optimizes the search for the host ACL entry. The range statement are displayed in the order they were entered. The hashing function is applied to the host statement. Routing access and ACL. The figure shows the logic of routing and ACL process. When packet arrives at the router interface, the router processes the same, whether ACL are configured or not. After the frame information is stripped off, the router checks for an ACL on an inbound interface. If an ACL exists, the packet is tested against the statements. If the packet matches a statement, the packet is entered permitted or denied. If the packet is permitted and after the router processes the packet, the outgoing interface will also be checked for an ACL. For troubleshooting standard IPv4 ACL, here's our examples. The most common error involved ACL entering ACE in the wrong order, applying ACL using the wrong direction, wrong interface, and wrong source address. In the figure of the left, the PC2, this is the PC2, should not be able to access the file server. However, PC1 cannot access it either. The output of the show access list command showed the one deny statement and the ACL. The setup command on the right show the solution. The permit statement allowed the device to access since the implicit deny was block other traffic. For our example 2, here's the example 2 of troubleshooting the standard IPv4 ACLs. And for example of troubleshooting standard IPv4, here's our example 3. Only PC1 should be allowed to SSH to R1. There is a problem with the config in the figure to the left since IP is unavailable to SSH to R1. The ACL is permitting the IP 192.168.10.1 address, which is G0/interface. However, the address that should be permitted in the PC1 host address of 192.168.10. And here's our topologies examples to troubleshoot the standard IPv4 ACL. And for our packet tracer troubleshooting standards, this packet tracer activity will require the troubleshooting of IPv4 ACL issues. And here's our topology examples for our packet tracer troubleshooting standard for IPv4 ACLs. And thank you.